What's up guys, it's Eduardo and today I'll be showing you how to find grams of H2 by starting with 25 grams of NH3. Okay, so that's the equation right there, it's the formula. And you gotta start with 25 grams of NH3 on the top left, and on the, because you're trying to find the moles first, you try to find the moles. So you're gonna put 1 mole of NH3, and then the grams of NH3 is 17, so you put that on the bottom left. Bottom right, sorry. And you're gonna get 1.47 moles of NH3. Then you're gonna put 3 moles of H2 and 2 moles of NH3 because H2 has 3 right here and NH3 has 2 right here. And then you're gonna get 2.20 moles of H2, and then there's 2 grams of H2, and then there's 1 mole of H2, and you're trying to find the grams of H2 so you're going to end up with 4.4 grams of H2 as your answer, and that's how you do it. Alright, bye.
Hey guys, Kenny here, and today we'll be looking at a limiting reactant problem for chemistry. So in this problem, 15 grams of CuCl2 react with 20 grams of NaNO3. How many grams of NaCl are produced, and what is the limiting reactant? So to start off, we'll be looking at the first reactant, which is 15 grams of CuCl2. And to start off, we want to convert from grams of CuCl2 to moles of CuCl2. To do that, we'll be dividing by the molar mass of CuCl2, which comes out to be around 134.45 grams. So if we divide that, I'll be moving on to my calculator here, by 15 and divided by 134.45, we'll be getting around 0.11. And I like to round at the end, so we'll just keep these numbers for now. Our next step is to convert from moles of CuCl2 to moles of NaCl, since that's a step in the right direction. So to find those numbers, we'll have to do the molar ratio, which is moles of NaCl over moles of CuCl2. And we'll find those numbers in the chemical equation, which is around up here. So if moles of NaCl can be found in this part here, which we can see to be 2. So that's 2 moles of NaCl. And moles of CuCl2 will come out to be 1 because there's no number out here, so it's assumed to be 1. And since it's 2 over 1, we will just be multiplying to get the moles of NaCl. So if I multiply by 2, I'll get around 0.22 moles of NaCl. Finally, what I want to do is convert from moles of NaCl to grams of NaCl. So we have to multiply by the molar mass of NaCl. As we can see here, it comes out to be around 58.45 grams. So our last step is to multiply by that number. So if we move on to our calculator here, we'll be multiplying by 58.45, which comes out to be around 13.04, which is grams of NaCl, which is what we got here. So we're not done yet, because this is a limiting reactant problem. So we have to solve for the second reactant, which is 20 grams of NaNO3. Our first step here is the same as what we did with the first reactant, which was going from grams of NaNO3 to moles of NaNO3. So to do that, we have to divide by the molar mass, and the molar mass of grams of NaNO3 is 85 grams. So if we do that in our calculator here, 20 divided by 85, yeah, will come out together around 0.235. And now that we have moles of NaNO3, we'll be converting that to moles of NaCl. And that requires us to find the molar ratio, which is moles of NaCl over moles of NaNO3. To do that, we'll be looking at our chemical equation again and get our numbers from there. So this is where you get 2 NaCl, 2 moles of NaCl, and 2 moles of NaNO3, because it says right there. So since the molar ratio is 2 over 2, which is basically 1, we can just multiply by 1 and we'll get the same answer. So now that we have moles of NaCl, we'll be converting that to grams of NaCl. And to do that, we have to multiply by the molar mass of NaCl, which comes out to be 58.45. So if I plug that into my calculator, there it did, and we multiply, we'll get 13.75 grams of NaCl, which is what I got here. And for limiting reactant problem, the answer will be the least amount of product. And as you can see here, it will come out to be around 13.04 grams of NaCl because that's our lowest number. And the limiting reactant would be CuCl2 because that's the reactant that ran out the fastest and produced the lowest amount of product. Hey guys, it's Kenny here, and we'll be looking at another limiting reactant problem. So in this problem, 20 grams of C2H4 are reacted with 30 grams of O2. How many grams of H2O are produced as a result, and what is the limiting reactant? So to start here, we'll be looking at the first reactant, which is 20 grams of C2H4. Our first step is to convert from grams of C2H4 to moles of C2H4. And to do that, we have to divide our grams of C2H4 by the molar mass of C2H4, which we found to be 28. So if I plug that into my calculator, so 20 divided by 28, we'll get around 0.71. So we got our moles of C2H4. Now we want to convert from that to moles of H2O because that's close to what we're looking for. So to do that, we have to do the molar ratio, which is moles of H2O over moles of C2H4. And to do that, we'll be looking at the chemical equation to find our moles. For the moles of H2O, we can see that it's 2 moles of H2O because of this number here. And for moles of C2H4, it's 1 because there's no number out here, so that means it's 1. So, since it's 2 over 1, we'll be multiplying by 2 to get the moles of H2O. So if I plug that again in here, I should get around 1.428. And I like to round at the end, so I'll just leave it at that. So, after that, after we get our moles of H2O, we want to convert from moles to grams of H2O, because that's what we're looking for. And to do that, we will be multiplying by the molar mass of H2O. So, we found that to be 18 grams. So, I'll just plug that into my calculator, and we'll get around 25.71. grams of H2O, which is what I got here. But since we're given two values, we'll have to look at the second reactant as well and compare them at the end. So our second reactant is 30 grams of O2, and the problem before, like the step before, we'll look at converting from grams of O2 to moles of O2. So we will divide by the molar mass, which is 32 for O2. So I'll plug that into my calculator over here, and we'll get around 0.9375. Now that we did that, we'll convert from moles of O2 to moles of H2O. So we'll be using the molar ratio again for that. So we get our numbers from the chemical equation once again. So we get 2 moles of H2O from this over here, and we get our moles of O2 from over here, which is 3. So the molar ratio would be 2 moles of H2O over 3 moles of O2. So let's work that out in my calculator. So since we have 2 on top, we'll be multiplying by 2. So we get that number. But then we'll have to divide by 3 as well, since there was a 3 on the bottom. So we'll get around 0.625 at that step. Finally, once we find our moles of H2O, we want to convert that to grams of H2O. And to do that, we'll be multiplying by the molar mass, which is 18 grams of H2O. So if I work that out in my calculator, we'll get around 11.25 grams of H2O, which is what I got here. And comparing between the two amounts of products, we can see that 11.25 grams of H2O was the lowest, so that would be our answer. And the limiting reactant would be O2, because that's the reactant that ran out the fastest and produced the lowest amount of product.